Hey, welcome back. Now, this is a bit of a bonus video. Can we combine Ladybug and Galapagos? This is a question coming up quite a lot, and there are not a lot of good videos out there which explains it in a very simple way. Most of them are diving deep into all kinds of complex ways on how you can use it. I will try to keep it super simple for everyone to understand. Now, let's jump right in. In the last video, we looked at the Ladybug view percentage tool. Back then, I thought, actually, should we not facet these cylinders, because we will not build completely round buildings. It's going to be difficult. But is there a way to facet these? And what does it do with and how should we facet it? What's the way, and can we create segments? What kind of size of segments works better with the view? That's actually quite an interesting one. But what do we need to do in order to use Galapagos with? So this is a bit of a tricky thing, no? So Galapagos, I'll go here and open this, try to open this. Where is it? So we have the Galapagos tool, and then we have the gene pool. So how can we combine this one with Galapagos? All right, let's get Galapagos here. First of all, it's not very intuitive. You don't link to Galapagos, you link from Galapagos. So for example, if I want to have a genome, the genome is basically just a slider. I can connect the slider. You can also understand it as a loop. If I want to have two sliders, I can use with the shift function, can select these. Now, these are linked with Galapagos. And then there's a fitness. This is the output. So for the output, I need a number. Anyway, let's go back first for a moment. What do we actually want to try? So my idea for this was, instead of having cylinders, can these be segments? And how many segments are there? How wide are they? And how are they rotated? And for that, we need actually a grasshopper model of this same thing. So let's build this first. I will turn off this stuff here, and let's build a script where we can actually create a segmented version of this. And I want to keep the same, I want to keep this geometry as a background, or as like a base where I can extract some information from it. First up, what could I do here? I could get the center point of these cylinders. So how do I get that? I can take a surface, can deconstruct, or maybe I think deconstruct BWrap. So I can get this in here. So first I'm gonna choose these. Oops, that's not what I want. Let's get all of them. Can place this in here. I have these faces, edges, and vertices. By the way, maybe I put the bifocus here so you get a better understanding. Sorry, I always forget to use this, but this is a pretty cool tool. Small tool, but very useful. Now, okay, if I place the square meter tool, I can see that I got these points here, area and centroid. So that's pretty good. But which should I choose from? This is the question. This is the bigger question here. And of course, they're also, what I did back then is they are not all on the same level. Anyway, we keep it like that first for now. But how could I choose these? So I could choose, let's see, probably better ways to do that, but I can choose the index list item. And now let's see if I can choose the item here. So basically what I'm trying to do here, I'll try to select the item. I only need one center point, and the one which is on the lower end, that's what I need. That's my goal. So I can have this, and I choose this by using a list item. I think I don't need the simplify method. I don't need that. Yes. So if this is a dashed line here, that means there are groups of data. There's more than one branch really as data. So there are faces in here, but faces are divided in 7 groups because there's seven buildings. Now I'm choosing the area inside. So I get, first of all, I get this like outline. I get the faces, edges, vertices, and then I have the area. and the centroids are these points. Now they're also divided in 7 groups. So if you go in here, you can see there are actually 7 data sets in there, and I choose one which seems to be the right point, the right vertices per group. If I choose 2, it's the upper one. If I choose 0, it's the one in the middle. So you can see this. Okay, now I have this selected. Now these are my center points. So we can get more out of this here. Now if I want to build polygons with segments, then I need to first know the radius here. So I have this tool, it's called Polygon, that I could place here in the plane of these vertices. So they are exactly here in the middle. That's great, but they don't overlap with the actual size of the building. Now I could do the same here. I could actually use this list selector to select the right edge. So I choose the edge here. I have now this edge is here selected. That doesn't really help me, but maybe it does because it can give me the height. And maybe I get another one here, and I choose something as 0. Yes. So this is now I have these circles here. Now I can measure the circles. I can deconstruct the arc, so I can measure the radius. So now I get the radius. By the way, I can all turn this off. I mean, I will not turn it off, but I will hide them. Are they not showing anything anyway? Okay. I get the radius. I can place this here. Now they are all aligned with the radius of the building, and I will keep it like that because I want to have them parallel anyway. But I could, of course, also play with... Now, you can see that the location here is not that great. So anyway, there's a gap. But I mean, this is details. I will try to keep it simple also. So now we have our radius accordingly. Now we could change the amount of segments, and you could do this individual. I will keep it simpler and just have one type. So we could say here, you can use even numbers or odd numbers. I use even numbers because that makes sure that it's always parallel. Or does it? Okay. Anyway, so I can choose here maybe 20. Okay. Place this in here because 0 doesn't work, 2 doesn't work. I need to have at least 6 or 4. So 4. Yeah, let's keep 4. At least 6, let's say. And then. So I need to make sure that it doesn't go below that. So my minimum is here 6. But now I maybe can turn off these because that maybe not as useful. And of course I need to extrude these. So let's extrude this. First I will close the polygon boundary surface. I'm not always finding these. Okay, now I have these as surfaces. I will hide this because it's a bit, yeah. Also this one, don't need that one. Don't need this one. I mean, this is a very simple script. I mean, you can make it much more sophisticated by, of course, align them properly and so on, but that becomes way too complicated. Let's keep it like this. I just want to give you an idea on how you can use this. Okay, let's extrude. I have a base, and then I have a direction. And I can use this here as a direction. That's not necessarily what I wanted. I use a set vector here. It probably works better. And then I just check the length of these. Instead of using it directly, I just check the length. So I get the length for each. And because they're all in order, this should be all based on my original model. So now we can actually use Galapagos already. So we can take this here. I'll get rid of this one because it will slow down the process quite a lot. Now I choose this as my context. That was not a good idea because it's always recalculating But yeah, it's not that crazy anyway. I will increase this here quite a lot, so the whole process is gonna be faster. Can't see anything at the moment, but now what I need to do, because I changed my geometry, so now I need to actually use this geometry for my test. So I can place this here. So if I'm opening this, should be correct. Yeah. And for the context, I also want to keep this, but I also want to bring in my geometry. So with Shift, I can add here the buildings as geometry. Now we have turned this off, so we don't see anything, but I can turn it on. That's the result at the moment. It looks a bit funny because it's triangulating the mesh. There are mesh settings we could play with, but let's keep it like that. Can also turn this off again, and we could maybe make this a bit more. Yeah, I think that's better. Now, what do we actually want to test? Okay. We want to maximize the green inside and outside. Like everything is green, we want to maximize. That means we want to maximize really the result. The total result we want to maximize. Just imagine, this is a percentage. If we could work in different ways with this, but ideally we want to get, like, the maximum would be 100% everywhere, and then everything count together. So this is the percentage per cell, and if we would like to have 100% per cell, then the overall number will increase. So I can go in here and do this, and you can see highest number is 48, and then it becomes less somehow. We could also, to simplify that, to just add everything. I'm gonna flatten this first. So I have just a number list, and then we can add everything. We use a mass addition that gives us this number here. And now what do we actually want to test? So we want to test if it's better to have big segments or smaller segments. I really don't know the answer, but yeah, we can try. So this is Galapagos. The fitness is the result, the goal. The goal is to maximize this end result. So the fitness goes in here. This is our fitness. And the segments is this one. Sorry. Again, I'm doing it wrong. So this is really the most simplest setup. We have one slider and we have one output, because we don't know we don't know what is better. I really don't know, honestly. I don't know if it's better to have smaller or larger segments. Probably larger could be more. I don't know. So now we can test this. We just double click here. It takes a bit to initialize. We can choose minimize or maximize. We can test both, or we can have a threshold, or we can place a goal ourselves. So we could place a number here if we want. By the way, there's all this online tutorial, online repository of knowledge about Galapagos. If you want, check it out. And then we have solvers, and we can record stuff. Anyway, let's keep it simple. Let's go to the solver. Now, we want to maximize. That's what we already said. We can limit the runtime if we want to a certain, to 1 hour and 30 minutes is here, but you can of course choose less. It will stop on its own when there's no better solution anymore. Okay, I will just, and imagine now you could do this for each separately. I'll just one to show you how that works. Okay, let's go here. I go to the solver, and now I start. And it's actually very simple. What it does, it just goes through the slider randomly, picking a random number from the slider. We only have 20, and checks what is the result. And if the result is bigger, then it will record that. We can actually go here and see every time the solver updates. I think we should see that. Okay, I changed a bit here. I want to change this to a bit more, so there's a bit more to calculate, just for the sake of test. And I realized that with only one slider, we should use this solver, the simulate annealing solver. That's what we should choose, so we can actually see something here. I might do another one in the next video, another video about the same topic. But in this case, yeah, let's stick with the idea and we'll not change it. It's a bit, yeah, I'm not sure. I mean, not sure how valid this is, but you know, it's about exploring, you know. So we understand, we might learn that actually this test is completely it's useless, but maybe not. I will start the solver. I changed the possible amount of segments to 100, and I also what else? Yeah, I changed the grid size to 1 meter, so it's a bit faster. Of course, if you have a lot of time, you know, you can make it smaller. But yeah, I'm gonna start this now, and you can see how it will show you some results. And you can also see that it goes through these different options. I'll stop this here, and you can see there's like this number on the top, which seems will not go above this really. So it's just stop it, and it stops wherever it is in the process, by the way. But you can click here on the highest number here. This is our goal. That was our goal. Can we maximize this? And now we can reinstate that. Let's compare. Okay, we can compare this. Yes, that's the number, and the segments are, how many segments do we have? 100. So I mean, it's a bit of a silly exercise really, but basically it says the closer you are to get to a perfect circle, the better. Yeah, just want to test this. There could be another way really to try something else, but yeah, this is one of the things you could try. Now you could, for example, add a different radius to each, or like different segment to each of these. So actually I could do this. That's maybe not a bad idea. And probably, I mean, the answer is gonna be the same. Just trying to give you more things to think about. So if we have 1, 2, 3, 4, 5, 6, 7, and let's limit this a bit more. Let's say, okay, we have 20. Let's not go overboard with this. Oops, sorry, no, that's not what I want. I want to limit this by 20, or maybe 40. Okay, 1, 2, 3, 4, 5, 6, 7. If you have something like this, then you can also use the gene pool. That's actually much more useful. So we could go in here and choose 40 as a maximum, and yeah, maybe let's do this. Maybe let's keep it like this, and then 6 is my minimum really, and I have 7. The only thing here is I can't choose to use odd or even numbers, but let's just try this as an option. So you could place here a second one, and another one, and another one, and so on, and they're all different, or you just do this, and it's just choose all of them, and this goes in here. So they all now have 23 sides, and then we can test this again. So the cool thing is we have only one output, one goal, but we have many the options of adding many of these genes or sliders. And now we can do this again. We can start here. And I want to see the change, so I can click this. And probably the result will be the more facets, the better for all of them. But you never know. You get the point. Now you see it's slightly increased compared to before, just a tiny bit. But let's stop this here and see what's going on. Okay, if we're gonna reinstate this, okay, that means, yeah, as predicted, of course, the more facets the better, but it could have been different anyway. So a bit of a silly experiment, but yeah, why not? Now we could do the opposite. What is the negative? And I want to show you, the minimum. What would be the minimum? That's also interesting. Maybe minimize the output. And let's have a look here. So it's a bit more interesting to look at. Interestingly, it's not as I expected it to be. All right, you get the point. Gonna stop this here. That's quite fun. Let's see. Let's reinstate this one. This option here was pretty much the last one. To the contrast of what I was thinking, that everything would go down to 6. Actually, it's not the case. It actually went to around 14, 12, and so on. So that's a surprise. That's worth actually a video.